In this video, we're going to continue our conversation that I started with you on 10.2 notes. So we started with just looking at arcs, and now we're going to start pulling into a whole bunch of theorems that have chords with them. Remember, a chord is a segment, and arc is going to be around the circle and just part of that area, part of that length around the circle. Okay, so we're just talking about kind of going from one part to another around the circle. This is just a little note here. Point Y is called the midpoint of arc X, Y, Z. If arc X, Y is congruent to arc Y, Z, that makes a lot of sense. Any line segment array that contains Y bisects the arc X, Y, Z. So that makes a lot of sense. All right, there are 4 theorems that we're going to go through today. So theorem 10.4 states, in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So we're going to draw the center of our circle, and I'm going to go like this. The best I can to try to make these congruent. Doesn't have to be perfect. That certainly isn't. So let me see if I can fix that. And it's not that easy to do these, but that's why we mark our diagram. So I'm going to mark that those are congruent. This is congruent to that. And then I'm going to come in here. I don't know that that's really in the center. And you might have some opinions about the distant learning. I know my own children do, and I would say that they are done with distant learning. They're very looking forward to going back to school when that time comes. All right, so anyway, 2 minor arcs are congruent if and only if the chords are congruent. So this just means arc DO would be congruent to arc ON. So this arc will be congruent to this arc if and only if the segments are congruent. So DO has to be congruent to ON. So segment DO has to be congruent to segment ON. So if these chords, remember a chord is a line segment where the endpoints are both on the circle. So if these 2 segments are congruent, then the corresponding arcs are congruent. It's really pretty intuitive. Theorem 10.5 states, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So I am going to put a point here for the center. I'm going to go ahead and draw my diameter. I'm also going to go ahead here and draw a segment there. And I'm going to say help, H, E, L, P. We all need some help sometimes, right? I'm also going to put an X here for this point. X marks the spot, so that intersection right there will be X. And I'm going to put a right angle. And what we know is since EP is a diameter, and EP is perpendicular to HL, then I know 2 things. I now know HX, segment HX, is congruent to segment XL, and I know that the corresponding arcs are congruent. So I know arc HP is congruent to arc PL. So let me say that again. So since EP is the diameter and segment EP is perpendicular to segment HL, now they're both chords. EP is the diameter, so it's a special case of a chord, but it's perpendicular to HL, so I'm getting that right angle. So because I have this very particular diagram, I now know that these segments are congruent, and I know that these arcs are congruent. and I'm just going to designate them with different tick marks. So the first set of tick marks corresponds to these two segments congruent, and the second set of tick marks correspond to these arcs congruent. So that's another theorem that we have. This theorem, theorem 10.6, matches up with it pretty much exactly. It's just saying if one chord is a perpendicular bisector of another chord, then the first chord is the diameter. It's pretty much the converse. So I'm just going to kind of go here and just say, okay, so if I have this particular diagram and I have F, I, R, E, and I know that those are congruent and that's a right angle, if you have that exact diagram, okay, so if you had this exact diagram where you had this chord and another chord and this length here, and I'm not going to, I guess I could put an S there if you want fires, plural, IS, segment IS is congruent to segment SE, and chord IE is perpendicular to chord FR. Because of that, I know FR, segment FR is a diameter. Okay, finally, this one's kind of a complicated diagram. So theorem 10.6. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So this one's going to be kind of hard to draw out, I think. Do the best you can. I would say try to maybe make one chord and then make another chord that looks about the same length. Doesn't have to be perfect. Okay, and then these two here are going to be congruent. And I'm going to have right angles. So that's a really kind of involved diagram. So I drew the two chords. I drew a segment from the center down perpendicular to that chord and from the segment perpendicular to that chord. And now I'm going to go ahead and label everything. So I'm going to do A, B, C, D, A, B, C, D, E at the center. I'm going to call this F, and I'm going to call this G. And I do need labels for everything, unfortunately. And I'm going to say AB, segment AB is congruent to segment CD if and only if, segment EF is congruent to segment EG. So the two chords are going to be congruent. So the chords are segment AB and segment CD, and they're going to be congruent only if the length from the center to the chord perpendicular to the chord are both the same length. So that's what this is saying. All right, so we'll start using these chords in practice over this week. Use all these theorems. Good luck.